All right, this lesson is for section 8.2. We're going to learn more exponent properties today. So for today's target, we're going to simplify expression using more properties of exponents. So our first property that we're going to learn is called the quotient of powers property, which we have nicknamed the subtraction property. Okay, so here we've got an example, and obviously this is a quotient because we are dividing, right? This is a to the 7th divided by a squared. Now if I were going to try to expand this and rewrite this, I would rewrite a to the 7th as a times a 7 times, right? 1, 2, 3, 4, 5, 6, and 7. And on the bottom I'm dividing that by a squared, or a times a. Now what's nice about this is that these a's here will actually cancel, because a divided by a, that's equal to 1. And so we have another a divided by a, which is also equal to 1. And that leaves us with the rest of this here, which is a to the 5th power. There's 5 left over. So there's a nice shortcut here. When you see powers that you're dividing with the exact same base, you simply subtract the exponents. So to fill in the blank here, when you divide powers with the same base, you subtract the exponents, and you're going to keep the base. So we kept a as our base, and we just subtracted 7 minus 2 to get 5. So let's go ahead and do some example problems. For number 1, we have x to the 10th divided by x to the 3rd. So again, we're going to keep the base, which is x, and we're going to just subtract 10 minus 3 to get 7. So this is x to the 7th power. There's my final answer. The next problem, same idea. We have the base. This time it's 2. So we're going to take the base of 2 and subtract 9 minus 4 to get 5. And then we can evaluate that in our calculator. 2 to the 5th is 32. So there's my final answer. Now this next one looks a little trickier just because the base here happens to be negative 4. But the same idea, we're going to keep our base, negative 4, and then we're going to subtract our exponents. So we have 8 minus 5, that gives me 3. Now we're going to use those rules that we talked about when we have a negative base and it's raised to an odd power. Overall, I know my answer should be negative. And then I'm just going to evaluate 4 to the 3rd power in my calculator to get 64. So the answer here is going to be negative 64. And then finally, for number 4, we have kind of a different looking problem here because right now just the 4 here is on the outside of the parentheses, so I'm going to distribute to both the 2 and to the a. So we have 2 to the 4th times a to the 4th over 4a squared. And I'm going to simplify a little bit further. So 2 to the 4th on top, this part here, I'm going to type that in my calculator and I get 16. So I have 16a to the 4th over 4a squared. Now when I look at this, I need to use my exponent properties, and that's only if I have powers with the same base. Well, 16 and 4, these are not powers. Okay, so we're going to do what we normally would do with 16 divided by 4. We're going to type that right in our calculator, 16 divided by 4, and we get 4. So we don't want to subtract 16 and 4 because they're not powers, but we are going to subtract our exponents here for a to the 4th divided by a squared. So we just use our new rule that we just learned. We're going to subtract the exponents to get 4a squared. And there's my final answer. Now our next rule is called the power of a quotient property. Power of a quotient property, which we're going to nickname, again, the multiplication property because it's the same idea. This time it's when you have a fraction or a quotient, right? Because this is a quotient with the division bar right here. And you're raising it to a power. In this case, we have a over b to the 4th, all raised to the 5th power. So what you're going to do here is actually distribute this 5 to both the a and to the base down below, this b here. So you're going to raise, whenever you raise a quotient to a power, you're going to raise the numerator, the top, and the bottom, the denominator, to that power. So you got to remember you're going to distribute that 5 to both the a and to the b on the bottom. So that would give us a to the 5th. And then on bottom, what we do when we have, when we have to distribute an exponent here, we actually multiply 5 times 4 to get 20. So we have a to the 5th over b to the 20th power. Okay, so let's practice this rule now. So for number 5 here, I notice that I have this 3 on the outside of the parentheses. So I'm raising this whole quotient to a power 3. So I know I have to distribute it to the top and to the denominator down below. So what I'm going to get when I multiply the exponents here, I'm going to get x to the 6th on top, and then of course this is a y to the 1st power, so when I multiply 1 times 3 I get y to the 3rd, and then on bottom 4 times 3, right, distribute it here and you get x to the 12th. Now when I look overall at this answer, I actually have an x to the 6th on top and an x to the 12th on bottom. these are powers with the same base. So what I have to do is simplify a little bit further. So I'm going to use that same rule that we just talked about. This time it's going to be a little bit different because the number on top is actually smaller than the number below, right? The exponent on top is smaller than the exponent below. So we're going to kind of think of this a little bit differently. This time I want to kind of draw it out first for you guys. So if I have 6 x's on top and I have 12 x's below, so there's 6 and then another 6. So all of these are being multiplied by each other, right? Well, what happens is the 6 on top actually get canceled out by 6 of them on the bottom, and left over we have x to the 6th power. Now if you notice, that's really like just taking 12 minus 6, but this time instead of putting them on top and leaving that as x to the 6th, there's actually x to the 6th on the bottom, okay? So when the number is bigger on the bottom, what we're going to do is still subtract, but the leftover number is actually going to go on the bottom. So I'm going to rewrite this. Let me erase all of this. When I simplify x to the 6th over x to the 12th, I'd have x to the 6th left over, but we're going to keep them on the bottom. And y to the 3rd would stay on top. So there would be my final answer. Okay, so if that problem was kind of confusing, don't worry about it. We're actually going to go over a lot more examples very similar to this idea tomorrow. I just wanted to show you one example of a case when you have an exponent that's got a higher number, you know, that's a larger number than the exponent in the numerator. So don't worry if it was a little confusing, we'll practice that a lot more tomorrow. Let's go to the next example. This one's a little bit more straightforward. Again, we have a power raised on the outside, so we're going to distribute it to the numerator and to the denominator. So I'm going to take -4 to the 2nd power. And this time, when I take negative to an even power, it's going to give me an overall positive number. So I'm going to drop that negative sign and just rewrite this as 4 squared. And on the bottom, y cubed to the 2nd power. Once I multiply, that will give me y to the 6th. Then I can go ahead and simplify the top using my calculator. Make that 16. 4 squared is 16 over y to the 6th. And there's my final answer here. Number 7 is pretty similar. We're going to take that 9 and distribute it to both the numerator, the a on top, and the b, the denominator here, the b on the bottom. So this is going to give me, when I multiply those exponents, a to the 18th power over b to the 63rd power. And I can't do anything further to simplify that since they are not the same base, so I leave my answer as a to the 18th over b to the 63rd power. Alright, now for our final problem, we're going to distribute this 3, okay? And we've got multiple bases on top. We've got the 3 and the x. So be careful that you don't, skip this -3 here. We're going to distribute it all the way here and to the x. And then on bottom, we've got 2 places to distribute that to as well. Y and z are both bases on the bottom. So this one, again, we're going to raise a negative to an odd power. So overall, I know my answer is going to be negative. So I would get 3 to the 3rd power, okay, and then x to the 3rd power, all over y to the 15th when I multiply 5 times 3, and z to the 6th when I multiply 2 times 3. Now to simplify this, -3 to the 3rd power is going to be -27, and then the x cubed stays the exact same along with the y to the 15th and the z to the 6th in the denominator, because there are no like bases to try to simplify any further. So that's my final answer here. Alright, so that's the end of the lesson. I know it was a little bit longer than normal, but good job. We'll practice this a lot more in class tomorrow. See you tomorrow.